Welcome to this session on the control paradigm, professional AI agent usage via the CLI. Today, we will explore a comprehensive blueprint for integrating artificial intelligence directly into professional software development workflows. By focusing on the command line interface, we establish a precise framework for managing AI agents, ensuring they serve as powerful and controllable assets within our technical ecosystems. Professional software developers don't just vibe with AI, they exert control over it. While the prevailing narrative often portrays AI agents as autonomous coders, a practice sometimes parodied as vibe coding, where developers lose touch with the underlying code, the reality for experienced professionals is quite different. As one survey respondent with 20 years of experience noted, while the shift away from manual coding is permanent, it does not mean a departure from high standards. A survey of 99 experienced developers reveals that they are not sacrificing quality for speed. Instead, they retain their agency by insisting on fundamental software quality attributes. When we look at the data regarding desired attributes when working with AI agents, correctness and readability emerge as the clear priorities. This indicates that professionals are not looking for a black box. They require code that is accurate and, crucially, code they can read and verify themselves. Other essential attributes like modularity, performance, and reliability also remain central to their workflow. Ultimately, for the professional developer, AI is a tool for enhancement, but the responsibility for quality and control remains firmly in their hands. The human in the feedback loop. Why control is essential. Keeping an experienced developer in the loop turns an AI agent from a black box into a powerful, high-fidelity collaborator. This partnership is crucial for 3 reasons. First, it allows for early course correction. Direct human supervision and direction steer the agent away from incorrect paths as early as possible. This prevents the costly conflicts and rework that arise when an autonomous agent misunderstands architectural constraints or business logic. Second, it fosters enhanced cognitive engagement. Human involvement leverages domain expertise and critical thinking. In this workflow, the developer provides the architectural vision and quality control, while the agent handles implementation details. As one software engineer noted, "I am a software engineer. I prompted by applying the lessons of software engineering to narrative." Finally, human oversight is vital for upholding professional standards. While agents generate code, professionals remain accountable for non-functional requirements, like architecture, maintainability, security, and performance. These qualities require human judgment that models cannot yet replicate. By maintaining control through the final output and code review, we ensure that every project meets the highest professional standards. Welcome. Today we are discussing why the command line interface, or CLI, is the ultimate interface of control for professional developers working with AI agents. While chat windows are popular for casual use, they often lead to ambiguity. As you can see on the left, natural language prompts like "make it better" or "fix the bug" are vague and difficult to reproduce consistently. Transitioning to professional tools means moving toward the structured environment of the terminal. On the right, we see an example of a precise command. By using flags and parameters, we define exactly what the AI agent should do, where it should do it, and how. This approach offers 3 fundamental advantages. First is precision and scriptability. CLI commands are explicit and repeatable. They remove the guesswork inherent in natural language, allowing developers to script and automate complex, multi-step tasks with total confidence. Second is workflow integration. The CLI is the native habitat of the developer. It does not require switching contexts because it integrates directly into existing tools, from terminals and shell scripts to Git hooks and full CI/CD pipelines. Finally, it provides a dedicated focus on the task. Unlike conversational UIs, which invite open-ended discussion, CLI interactions are transactional and results-oriented. They are built for efficiency and for getting a specific job done. For the professional developer, the CLI is not just a tool, it is the interface of control. Welcome to an overview of the professional CLI toolkit. We are seeing the emergence of a new ecosystem of CLI-first tools, specifically built for developers who prioritize control over vibing. This data comes from a 2025 survey of 99 experienced developers, which identified several agentic tools now being integrated into professional workflows. Our primary case study is AMP CLI. AMP is a frontier coding agent designed for both the terminal and the editor. It is built for multimodal usage and utilizes structured delegation via subagents to provide deep workflow integration. Within the broader ecosystem, we also highlight OpenCode CLI. This tool represents a growing class of CLI-based agents that focus strictly on developer control. As the research suggests, professional software developers don't just vibe, they control. These tools are the foundation of that philosophy. Let's explore a case study on precision using AMP CLI's execute mode. For quick, one-off tasks, a full conversational thread is often unnecessary. AMP's execute mode, activated with the -X flag, acts as a developer's scalpel, performing a single targeted task and then exiting. The basic syntax is simple. Just run amp-x followed by your prompt. In our first example, we see how this is used for generating documentation. A direct instruction for a standard task, such as create a readme.md with installation and usage instructions, is handled quickly and efficiently. In our second example, we see how execute mode integrates with standard shell commands for more complex inputs. Here, we are creating release notes from a template by reading detailed instructions from a text file and redirecting the output to a new document. The key takeaway is that execute mode provides a direct, non-interactive way to leverage AI for specific, well-defined tasks. Moving beyond one-off interactions, we can integrate AI directly into professional development workflows. The real power of execute mode is that it extends far beyond simple command line usage. Because the amp-x command is scriptable and operates non-interactively, it can be seamlessly embedded into automated development pipelines. Let's examine two primary paths for this integration. First, we have Git hooks. By utilizing a pre-commit hook, we can automate essential but often overlooked tasks. For example, every time a developer initiates a git commit, the system can automatically trigger a command like amp-x update documentation before the commit proceeds. This ensures that documentation and change logs stay perfectly in sync with every code change. Second, we can integrate AI into CI/CD pipelines. In this scenario, once code is pushed to a build server, automated AI-driven checks are executed as part of the standard build process. By running a command such as amp-x run a security check, we can perform real-time analysis for security vulnerabilities, code style compliance, or general quality. The output of these AI-driven checks then directly determines whether a build passes or fails. By embedding AI into these foundational processes, we transition from manual assistance to a more robust, automated, and high-quality development lifecycle. Structured delegation is a powerful way to orchestrate subagents for complex tasks. By breaking down large objectives, we can parallelize work effectively. Using AMP, developers can spawn individual subagents for tasks that benefit from independent execution. Critically, each subagent operates within its own context window and has its own tool access. This is not about uncontrolled autonomy, it is structured delegation. The human developer acts as the central orchestrator, defining specific subtasks and assigning them to specialized agents. Subagents are particularly ideal for performing parallel work across different parts of a codebase, managing tasks that produce extensive output without cluttering the main context, and keeping the primary conversational thread clean and focused. As seen in the diagram, the developer directs multiple subagents simultaneously. A practical example of this in action would be a prompt like, convert these 5 files to use Tailwind, use 1 subagent per file. This approach ensures efficiency and clarity in complex development workflows. User-guided context is essential for any AI agent's effectiveness, as its performance depends heavily on its understanding of a project's unique context. In our workflow, AMP utilizes agents.md files to absorb project-specific guidance directly from the developer. Developers use these files to provide explicit instructions on several key areas. This includes the code-base structure and architecture, project-specific build and test commands, coding conventions and style guides, and common mistakes to avoid. As you can see in the diagram, the information contained in the agents.md file feeds directly into the AI agent context model. By maintaining this file, the developer continuously refines the agent's knowledge base. This ensures that the agent acts as an informed collaborator that respects the project's established patterns. Furthermore, because this information resides in a Markdown file, it provides a durable, version-controlled form of context management. The control paradigm represents a complete workflow for professional agent usage. It is built on a structured, iterative cycle designed to ensure the developer always remains in command. The cycle begins with planning. In this stage, the developer defines the task, architects the solution, and breaks the work down into manageable steps. This process often involves creating or updating a dedicated agents.md file to maintain a clear roadmap. Next, we move to direct. Here, the developer provides instructions to the agent using precise tools. For simple, one-off tasks, this might involve a direct command line prompt. For more complex or parallel workloads, this stage involves strategic sub-agent delegation. Once the agent produces output, we enter the validation phase. The developer is responsible for reviewing all generated content, which includes reading the code, running tests, and verifying that everything aligns with the initial requirements. In this paradigm, the developer is the ultimate arbiter of quality. Finally, we reach integration. Once the code is fully validated, the developer commits it to the codebase, utilizing standard version control practices like Git. This completes the cycle, ensuring a controlled, professional, and high-quality development process. When we look at the landscape of modern software development, we see a clear divide in how professionals approach their work. We call this choice control, not vibes. On one hand, there is the vibe coding myth. This approach seeks full autonomy and a sense of flow, but it often reduces the human role to that of a passive observer. By relying on ambiguous chat interfaces and black box agents, the development process becomes one of unpredictable, iterative guessing. Ultimately, this leads to low-quality, inconsistent code. In contrast, the control paradigm focuses on productivity with quality. Here, the developer acts as an active orchestrator of the entire system. Instead of vague prompts, we use a precise command line interface with specialized tools like AMP and the open code CLI. Our process is deliberate. We plan, direct, validate, and integrate. This structured methodology ensures that the final outcome is professional-grade, maintainable software. Choosing the right paradigm is about moving away from guesswork and reclaiming professional control over our craft. The future of software engineering is defined by augmentation, not replacement. The most effective use of artificial intelligence is not found in attempting to replace the developer, but in augmenting their expertise with powerful, precise, and controllable tools. By embracing this control paradigm, experienced developers can amplify their existing skills and automate tedious, repetitive work. This shift allows engineers to focus their energy on high-level architectural and creative challenges, where human judgment provides the most significant value. Furthermore, we view the command line interface as the natural nexus for this powerful human-AI collaboration. It provides the necessary precision and deep integration required to build the next generation of software.